So there is hypochlorous acid and hydrochloric acid when chlorine reacts with water. This is the one we are calling hypochlorous acid, HOCl. Then the formula for hydrochloric acid is just this. Then I asked another question. A blue litmus paper was added to the resultant solution. This is the resultant solution, which contains hypochlorous acid and hydrochloric acid. I told you something, that when a blue litmus paper is added to this solution of chlorine water, the blue litmus paper turns to red. Why does it turn to red? It is because of the presence of this hydrochloric acid. So, you know, all acids turn blue litmus paper to red. So hydrochloric acid turns this blue litmus paper to what? To red. Then after, to red, and then bleaches it. We said bleaching is losing of color. Most of the time we have seen girls who have bleached their skins. Someone was black and now bleaches the skin and looks now yellow. Yes. So almost white. So bleaching is the losing of color. So this red litmus paper, after turning from blue, it will now change to white, to lose its color from red to what? To white. What is causing it to lose the color from red to white? It's the hypochlorous acid. So a solution of chlorine contains hydrochloric acid, which turns the blue litmus paper red, and hypochlorous acid, which bleaches the red litmus paper. So it's the bleaching action. Okay, the bleaching action is due to the formation of hypochlorous acid. We have already talked about it. And we said dry chlorine or chlorine without water does not bleach. Why? Because it won't contain the hypochlorous acid. So dry chlorine does not bleach, and it extinguishes the burning sprint. So that's where we stopped last time, and now let us use the remaining time to go through this work. Test of chlorine. Like any other gas, for example, carbon dioxide, we say it is a colorless gas that turns lime water milky. So likewise, chlorine gas, its test, we say it is a greenish yellow gas which turns the moist blue litmus paper to red. You have a summary book, you should have written that. Test for chlorine gas, it is a greenish yellow gas that turns moist blue litmus paper to red and then bleaches it. I've already told you what bleaching means. The red litmus paper will turn it white. Formerly it was blue, but due to presence of hydrochloric acid, it turns to red and then is bleached by hypochlorous acid. This is because the gas is acidic. That's why the red litmus paper, the blue litmus paper, turns to red. Chemical properties. This is very important. Chemical properties. Chlorine as a bleaching agent. So what we are going to describe an experiment to show that chlorine is a bleaching agent. And before we go any further, let us look at this. At home, when you are washing, you can be washing sometimes. I think you have ever seen someone putting jik in the clothes, especially white clothes. Jik, the largest percentage of jik is chlorine. Now, if you have a white shirt and it has some stains, some colored stains, you apply jik to remove those colored stains. I've told you, jik, the largest percentage of it is chlorine. Eh? You even hear how it smells. It smells like water guard. Eh? Chlorine, actually, water guard is also chlorine. It contains chlorine, which is put there to kill germs. Then jik also contains chlorine because chlorine will bleach those colored stains and turn them to white, or it will remove them and turn them to white. So pour a little litmus solution into a glass jar of chlorine, and the litmus immediately turns colorless. So the litmus immediately turns colorless. You know, litmus solution is colored. It is either blue or red. So when you add chlorine, it will immediately turn what? Colorless, meaning chlorine has removed the what? The color. Observation, chlorine bleaches the color from most dyes. Not a dye is like a piece of the shirt I was telling you about, the white shirt, and will remove the color from writing ink, but not printer's ink, which consists mainly carbon, and chlorine does not attack. So chlorine does not react with carbon. That's why it does not remove printer's ink. So other writing materials which are not carbon, they will be bleached by chlorine. The bleaching action of chlorine. I want to tell you this is very, very important. Bleaching action of chlorine. How does chlorine remove the color? What happens when chlorine is added to that white shirt with stains? First of all, chlorine reacts with water to form hypochlorous acid. I've been telling you all along that the hypochlorous acid is the one responsible for the bleaching effect. Hydrochloric acid, for it, turns the blue litmus paper to red. But hypochlorous acid is the one responsible for the bleaching effect. So the first thing that happens is that when you are washing, the chlorine first reacts with water to form hypochlorous acid. So when I ask you to state the bleaching effect to describe the bleaching effect of chlorine, you first write this equation: chlorine plus water forming hydrochloric acid plus hypochlorous acid. The hypochlorous acid is a very reactive compound and readily gives up its oxygen to the dye. So removing the color, this is our equation, very common equation. Please, all of you must learn this equation. We have a dye that is colored. Now when we add hypochlorous acid, we are saying the hypochlorous acid will give up its oxygen to the dye. And when it gives up its oxygen to the dye, we shall form hydrochloric acid. So the hypochlorous acid, which was colored, we said it is a yellow solution, will now turn to hydrochloric acid, which is colorless, because it has lost its oxygen. It has lost its oxygen to the dye. So the dye now gets the oxygen and it is also now colorless, plus hydrochloric acid, which is also colorless. So if it is a solution, it turns to colorless. If it is a dye, like a cloth material, it will turn to white. So hypochlorous acid bleaches by oxidizing the dye. Oxidizing means it adds oxygen to the dye. And this equation is very important. So dye plus hypochlorous acid, the hypochlorous acid gives up its oxygen, this one, to the dye, and it remains as hydrochloric acid, plus then the dye plus oxygen, the oxygen that has been given up by hypochlorous acid. The hypochlorous acid turns the colored dye colorless by oxidation. by oxidation reaction, since it gives up its oxygen to the colored dye. So that has been the bleaching effect of chlorine. But we said the dry chlorine, when there is no water, it will not bleach because there will be no hypochlorous what? Acid. Then chlorine is also used to kill germs and bacteria in drinking water. If you have ever taken water that is treated with water guard, you have ever smelled that chlorine, you know how it smells. Let us look at this one, effect of sunlight on chlorine. Now, this is also very, very important. How do we do that? You just insert a gas jar. This is a gas jar containing chlorine. You insert it in a beaker of water and then you expose it to sunlight. Whenever chlorine reacts with water, there are two products. There is hydrochloric acid and hypochlorous acid. Then now when the hypochlorous acid is exposed to sunlight, it will give up oxygen. So here you observe bubbles of a colorless gas, which is oxygen. We are saying pass chlorine gas into water in a beaker, and the water becomes yellowish brown, yellowish green. This should be yellowish green. The water becomes yellowish green, i.e. chlorine water is formed. Chlorine water, I keep telling you, it is chlorine water is this one. This is the chlorine water. When we say chlorine water, it is hydrochloric acid plus hypochlorous acid. Fill a long tube with this chlorine water and invert it in a beaker containing some water and expose to sunlight. So this is our beaker containing chlorine water, and this is water. Now we expose to sunlight. After some time, the gas collects in the tube, and on applying, you know how we test for oxygen gas. Isaac, how do we test for oxygen gas?
The use of a burning splint.
0. Ruth.
It's a lower glowing splint in a gas jar containing oxygen.
We
Lower a glowing splint in a gas jar containing oxygen.
Yes. So that's how you test for oxygen. Please, burning splint is for hydrogen. For oxygen, we use a glowing splint. So after some time, the gas collects in the tube, and on applying a glowing splint, the gas is, this word rekindled, it means relight. It is the glowing splint relights. So if this word becomes difficult for you, just say the glowing splint relights. So in short, when chlorine water is exposed to sunlight, chlorine water, which is hypochlorous acid, oxygen gas is produced. And we should have an equation there. Our equation is here. Chlorine plus water form hydrochloric acid plus oxygen. So the above reaction occurs instantaneously in the two stages. So this one will confuse you. Let us go with these two that we already know. This is chlorine plus water. We form chlorine water, which is hypochlorous acid plus hydrochloric acid. Then the hypochlorous acid is the one that gives up oxygen, and we form oxygen plus hydrochloric acid. So let us go with these two equations. The first one here was got by adding up these two, by adding up them together, but we can go with these two. The first one is chlorine plus water forming hypochlorous acid plus hydrochloric acid, and then the other one is hypochlorous acid being split by sunlight. The role of sunlight is to split that hypochlorous acid to form hydrochloric acid plus oxygen. Then let us look at action of chlorine with alkalis. You people, this is very important. We shall do it even up to senior 5. Action of chlorine on alkalis. No, we have already seen that chlorine gas is also acidic, if you remember very well. And if it is acidic, then it must react with alkalis. Alkalis, I mean the bases, that is sodium hydroxide, potassium hydroxide. So if chlorine is acidic, it must react with them. So chlorine reacts with dilute aqueous solutions of sodium and potassium, forming a pale yellow solution of the hypochlorite and chloride of the metals. Very simple. When you have chlorine and you add sodium hydroxide, we are saying it forms a hypochlorite. This is sodium hypochlorite plus sodium chloride plus water. Now, you balance by putting a 2 on sodium hydroxide. And we are saying, when we ask for the observation, why should you fail? The observation, we are saying a pale yellow solution is formed. What is the pale yellow solution? The pale yellow solution is sodium hypochlorite, because sodium chloride, we know that it is colorless. So take note of this equation. But this only happens, the condition for this to be formed, sodium hypochlorite, is that sodium hydroxide or potassium hydroxide must be cold and dilute. Must be cold and dilute. In chemistry, we like conditions. So when sodium hydroxide is cold and dilute, we form sodium hypochlorite plus sodium chloride plus water. And the same thing, what sodium does, potassium will do. For potassium, it will be potassium hypochlorite plus chlorine, then plus water. The ionic equation, we shall study the ionic equations later on when we come back to school. Now, that has been called and dilute sodium hydroxide or potassium hydroxide. When it is hot and concentrated sodium hydroxide, the products are going to change. Instead, we shall form sodium chlorate or potassium chlorate. This is potassium chlorate. You remember we use it in preparation of oxygen, plus potassium chloride, then plus water. This is only possible when sodium hydroxide is hot and concentrated. Sodium hydroxide or potassium hydroxide is hot and concentrated, we form potassium chlorate. This equation is also not easy to balance, so the easiest way to balance it is by putting 6 on potassium hydroxide. When an equation is not easy, we agreed I will always tell you. Reaction with chlorine, of chlorine with hydrogen. Just burn dry hydrogen gas with chlorine and you'll form hydrogen chloride gas. And this is the equation. Dry chlorine plus hydrogen gas to form hydrogen chloride gas. I want to stop there. I want to stop here for today. I want us to go slowly, but the few things that I teach you in a day, you must understand them. We have 1.5 minutes remaining. Any question from you? Who has a question? After here, I'm going to give you work. Please, why just unmute and ask a question. Why do you send messages? Why can't our costumes turn white when we enter the swimming pool? We don't put a lot of chlorine. Someone is asking, why don't our costumes turn it white when we enter swimming pool containing chlorine? When you are in a swimming pool, I want to ask you, does that swimming pool smell like jik? Eh? It does not. Then that shows you that the amount of chlorine which we put in a swimming pool is very little, just to kill germs, but not to turn the costumes to white. If you want the costumes to turn to white, then we put an equal amount of chlorine which we put in jik. So the answer is there is little chlorine in the swimming pool just to kill germs. I think I've answered you, Blighter. Another one? Remember, the rest of the questions, you can send them to my inbox. Go through the notes. I think you all go